Now, in the questions, we are given a passage in which we are given that let S be a circle in xy plane defined by the equation x square plus y square equals 4. So we have this circle with center at origin and radius equals 2 units. Let E1, E2 and F1, F2 be the chords of S passing through the point P0, 1, 1 parallel to x-axis and y-axis respectively. Let G1, G2 be the chord of S passing through P0 and having slope -1. Let tangent to S at E1, E2 meets at E3 and tangent to S at F1, F2 meet at F3. The tangent to S at G1, G2 meet at G3. Then the points E3, F3 and G3 lie on which of the following curves? Now it says we have this point P0 which is 1, 1 and 1, 1 is going to lie inside this circle. So this point is P0. Then a line passing through P0 parallel to x-axis and we have a line passing through P0 parallel to y-axis. So this is E1, E2 and this point is F1 and this other point is F2. Now this line is y is equal to 1 and this is the line x equals 1. Now if we put y equals 1 here, we'll get x is plus minus root 3. So this E1 is minus root 3, 1 and E2 is root 3, 1. And if we put x as 1 in this equation, we'll get y as plus minus root 3. So it will be this 1, root 3 and 1, minus root 3. So we have coordinates of E1, E2 and F1, F2. Now it says let G1, G2 be the chord of S passing through P0 and having slope -1. So this is this line which passes through P0 and slope of this line is -1. So equation of this line will be y -1 minus 1 x -1 or simply x plus y equals 2. So this point basically G1 is 0, 2 and G2 will be 2, 0. Now it says tangents to S at E1 and E2 meets at E3. So if we write tangent at E1, it is given by t equals to 0. So this equation will be minus root 3x plus y. It is equal to 4. And at E2, again will be t equals 0. So there will be root 3x plus y and it is equal to 4. Now here we get y as 4 and x as 0. So basically coordinate of this point E3, it is 0, 4. Then the same way we can write equation of tangent at F1. Now at F1, equation of tangent is given by x plus root 3y equals 4 and x minus root 3y equals 4. Now here x is 4 and y is 0. So that's your F3. It says tangents at G1 and G2 meet at G3. Now G1, G2, they are here, right? So this point of intersection will be simply 2, 2. So this G3, it is 2, 2. And these 3 points, they are collinear and they lie on this line. X plus y is equal to 4. So answer to this question is this option A, x plus y equals 4. Now the second part is let P be a point on the circle S with both coordinates being positive. Let tangent to S at P intersect the coordinate axis at points M and N. Then the midpoint of line segment MN must lie on this curve. So we have to find basically locus of midpoint of MN. Now suppose there is a point P and we'll take this P in terms of parameter coordinates. Let it be 2 cos theta and 2 sin theta. Then we know that equation of tangent is given by t equals 0. So this equation will be 2 cos theta x plus 2 sin theta y. It is equal to 4, or x cos theta plus y sin theta equals 2. Now it intersects x-axis and y-axis at m and n. So this m will be 2 secant theta comma 0, and this n will be 0 comma 2 cosec theta. Now we will find locus of midpoint of mn. Now suppose this point is alpha comma beta, so we'll get alpha as secant theta and beta as cosec theta. Now we'll eliminate theta. We know that sin square theta plus cos square theta is 1, so we'll get 1 upon alpha square plus 1 upon beta square equals 1, or alpha square plus beta square equals alpha square beta square, and then we replace alpha with x and beta with y. So this required locus will be x square plus y square equals x square y square, and that's your option D. So it matches with this option D. Now here the question is, let T be a line passing through the points P, Q, and let F1 be set of all points of circle such that T is tangent to S1 at P and tangent to S2 at Q, and also such that S1 and S2 touch each other at a point, say M. Let even be the set representing the locus of M as the pairs S1 S2 varies in F1. Let the set of all line segments joining a pair of distinct points of E1 and passing through all the points R be F2. Let A2 be set of midpoints of line segments on the set F2, then which of the following statement is or are true? Now we are given this straight line and we have 2 points on this line, and there are 2 circles which touches the straight line at these points P and Q. So we have 2 points on this line and there are 2 circles. Now suppose this is your point P, minus 2 comma 7, and Q is 2 comma minus 5. This is S1 and this is S2, and this set is F1. Suppose their centers are at C1 and C2. And they touch each other at this point M. So this F1 is set of all circles and E1 is set of locus of M as S1 S2 varies. Let set of all straight line segment joining pair of distinct points of E1 passing through point 1 comma 1. Now let us draw this perpendicular line from M. So this is 90. Let's join these 2 lines. Now this is 90 and this is 90. And we have joined P with M and Q with M. Now let this angle be theta. Then this angle here will be theta. Then angle at the center will be 2 theta. And this angle here will be pi minus 2 theta. In the same way, if this is alpha, then here it will be this 2 alpha. This angle will be pi minus 2 alpha. Now sum of these 2 angles, it is pi, so we can write 2 pi minus 2 theta plus alpha, it is equal to pi, or theta plus alpha is equal to pi by 2. That means this angle PMQ, it is always 90 degrees. And if PMQ is always 90 degrees, then locus of M is circle with PQ as diameter. So basically this E1, which is locus of M, it is the circle drawn through PQ as diameter. So this E1 will be given by x plus 2 into x minus 2 plus y minus 7 into y plus 5 equals to 0. So this E1 will be given by x square plus y square minus 2y minus 39 equals 0, except these points P and Q. So this M, it cannot take these 2 points P and Q. So we have to exclude these 2 points except PQ. So this is the locus of this point M. And basically we can write this as x square plus y minus 1 whole square equals 40. Now it says we have this circle and E2 is set of midpoints of this chord. So E2 is set of midpoints of the chord which pass through this point 1, 1. Now let this point be alpha beta. We know that equation of a chord whose midpoint is given, it is given by T equals S1. So in this case, this equation will be given by alpha x plus beta y minus 2 y plus beta upon 2 minus 39, and that will be equal to alpha square plus beta square minus 2 beta minus 39. Now this minus 39 will cancel. And this chord, it passes through 1, 1. So we'll put x as 1 and y as 1. So we'll get alpha plus beta minus 1 minus beta, and that will be equal to alpha square plus beta square minus 2 beta. Now here beta and beta will cancel. So we'll get this locus as alpha square plus beta square minus alpha minus 2 beta plus 1 equals to 0. So locus of E2 will be this circle which is x square plus y square minus x minus 2y plus 1 equals 0. Now we have to check the 4 options. So now we have the 2 locuses. E1, which is x square plus y minus 1 whole square, and it is equal to 40, except the 2 points P and Q. P, which is minus 2, 7, and Q, which is 2, minus 5. And this other locus, which is E2, and that is x square plus y square minus x minus 2y plus 1 equals 0. And since E2 is midpoint of chord of this circle passing through 1, 1, so it'll have all the points except chords which pass through P and Q. Since P and Q, they are not included on E1, so any chord which starts from P and Q will also not be included in this second locus E2. Now we look at the options. Now the first option is point minus 2, 7 lie on E1. Now minus 2, 7 is basically point P, which is not included on E1. So that means this option A is incorrect. And this option D is the point 0, 3 by 2 does not lie on E1. So we'll put the value of x and y. We'll put x as 0. So it'll be this 0 plus, now 3 by 2 minus 1 is 1 by 2, 1 by 4. It is equal to 40, which is incorrect. That means it is correct that this point 0, 3 by 2, it does not lie on E1. So that means this option D is correct. Now we look at this option B. Now we look at this option B. We are given this point 4 by 5 and 7 by 5, and it says it does not lie on E2. Now we'll put the value of x and y in E2. So we'll get 16 by 25 plus 49 by 25 minus 4 by 5 minus 14 by 5 plus 1. It is equal to 0. Now this is 49 plus 16, 65 by 25, which is 13 by 5 minus 18 by 5 plus 1, which is 0. That means this point, it does lie on E2, but we have this other condition that any chord must not pass through P and Q. So we have to find whether this point 4 by 5, 7 by 5, 1, 1, and then P or Q, they are collinear or non-collinear. So we'll solve this determinant. So what we'll do is we'll take C1 minus C2 and C2 minus C3. Now 4 by 5 minus 7 by 5, it is minus 3 by 5, and 7 by 5 minus 1 is 2 by 5. This is 1. This is 0, 0, 1, and this is minus 9, 6, and 1. Now if we expand it above this second row, we'll get this as minus 18 by 5 and plus 18 by 5, and it is equal to 0. That means these 3 points, 4 by 5, 7 by 5, 1, 1, and P, they are collinear. So this chord will actually pass through P, and since the chord passes through P, this point, it cannot lie on E2. That means this option B is correct. So the point does not lie on E2, though it satisfies its equation. Now this third one is point 1 by 2, 1 lies on E2. So now we'll put the value of x as 1 by 2 and y as 1. So it will be this 1 by 4 plus 1 minus 1 by 2 minus 2 plus 1. So we'll cancel, and this is minus 1 by 4, which is unequal to 0. So this point C, it does not lie on E2. So the only correct options are B and D. Now the question is, consider two straight lines, each of which is tangent to both the circles x square plus y square equals 1 by 2 and parabola y square equals 4x. So we have a circle and a parabola. Equation of circle is x square plus y square equals 1 by 2. And then we have this parabola, which is y square equals 4x. Here the value of a is 1. Then we have pair of tangents common to both this circle and parabola. And these lines, they intersect at this point Q. Now first we have to find this point Q. Now equation of tangent to this circle will be given by y equals mx plus minus r, which is 1 by root 2 under root 1 plus m square. And equation of tangent to this parabola will be given by y equals mx plus a by m, and a is 1, so it will be this 1 by m. Now since we are talking about common tangent, slope is same and the equation should be same. So here we'll get this condition that plus minus 1 by root 2 under root 1 plus m square, it should be equal to 1 by m. When we square it, we'll get m to the power 4 plus m square minus 2 equals 0, or m square plus 2 into m square minus 1 equals to 0. So value of m is either plus 1 or value of m is minus 1. So we have two lines. One of the slope is 1 and the other slope is minus 1. Now we put m as 1, we'll get equation of tangent as y equals x plus 1, and the equation of other tangent is y equals minus x minus 1. Now they'll intersect at minus 1 comma 0. So coordinate of this point Q is minus 1 comma 0. Now it says consider an ellipse whose center is at origin and whose semi-major axis is OQ. So we have an ellipse with center at origin and semi-major axis is this A, and this A is 1. And length of minor axis is root 2. That means 2b is root 2, so b is 1 by root 2. Then which of the following statements is or are correct? Now first we have to find its eccentricity. Now we know that b square is a square into 1 minus e square. So we'll get this as 1 by 2 and this is 1 minus e square. So value of e is 1 by root 2 and length of latest rectum is 2b square upon a. So it will be this 2 and b square is 1 by 2 and a is 1. So length of latest rectum is 1. So eccentricity is 1 by root 2 and length of latest rectum is 1. That means this option A is correct and option B is incorrect. C is area of region bounded by ellipse between the lines x equals 1 by root 2 and x equal to 1. So here we are talking about this ellipse. Its center at origin, focus at 1 by root 2 comma 0 and this point is 1 comma 0. So we are talking about this area. Now since there is a symmetry in the problem, area above x-axis is same as area below x-axis. So this area will be 2 times and then this integral from 1 by root 2 to 1 and then y dx. Equation of this ellipse is x square plus 2y square equals 1. So value of y is 1 by root 2 under root 1 minus x square. So it will be this 1 by root 2 into under root of 1 minus x square dx. Now this is simply root 2 and this area it will be root 2 and here will be this x by 2 under root 1 minus x square plus a square upon 2 sine inverse x from 1 by root 2 to 1. Now we will simplify this. So this area it will be root 2 and if we put x as 1 it will be 0 minus if we put 1 by root 2 it will be 1 upon 2 root 2 and then into under root of 1 minus 1 by 2 plus 1 by 2 and here it will be this sine inverse 1 minus sine inverse 1 by root 2. Now this is root 2 and here this is minus 1 by 4 and plus 1 by 2 and sine inverse 1 is pi by 2 and here this is pi by 4. So this is pi by 8. So it is root 2 into pi by 8 minus 1 by 4 and we can write this as pi minus 2 upon 4 root 2 square unit. So area between x equals 1 by root 2 and x equal to 1 is 1 upon 4 root 2 into pi minus 2 and that's your option C. So the correct options are A and C. Now here the questions. Let point B be the reflection of point A with respect to this line. So we have this point A which is 2, 3 and this line say L which is 8x minus 6y minus 23 equals 0. Now reflection of this point about this line L is B. So we'll use image of a point formula. So it will be this x minus 2 upon 8 y minus 3 upon minus 6 and then minus 16 minus 18 minus 23 upon 64 plus 36. That will be 100. Now this is 25, 50. So this value is 1 by 2. Now this is 4 plus 2, 6. So coordinate of this point B will be 6 and here this is minus 3 plus 3, 0. So coordinate of point B is 6, 0. Now it says let tau A and tau B be circles of radius 2 and 1 with centers at A and B respectively. So we have this point A which is 2, 3 and we have circle of radius 2 drawn from it as a center, and then we have this other point B, which is 6, 0, and here its radius is 1 unit. Now it says T is a direct common tangent between the two circles, and this direct common tangent intersects this line joining AB at this point C. We have to find this AC. Now we know that this C, it is going to divide AB in the ratio R1 is to R2. So we'll divide AB in the ratio 2 is to 1 externally. So coordinate of this point C will be 12 minus 2 upon 1. Will be 0 minus 3, and here it is this 1. So coordinate of this point C, it is 10 comma minus 3. Once we have A and C, we can find AC. So this AC will be under root of, now this is 10 minus 2, 8. So it will be this 8 square, and plus 3 minus 3 is 6. 6 square, there will be 100. So this value is 10. So length of this line segment AC is 10, and that is the answer to this question. Now here the question is, let the circle C1, C2 intersect at points X and Y, and suppose that another circle X minus H square plus Y minus K square equals to R square satisfy the following conditions. Center of C3 is collinear with centers of C1 and C2. C1 and C2 both lie inside C3, and C3 touches C1 at M and C2 at N. So basically we have two given circles, and this first circle center at origin, and radius 3 units. This second circle with center at 3, 4 and radius 4 units. So here this radius is 3 and this radius is 4 units, and distance between center is 5. So basically this angle is 90 degrees. Now it says we have another circle whose center is C3, which is collinear with centers of C1 and C2, and C1 and C2 both lie inside C3 and it touches them at M and N. So we have this circle which is going to contain both the circles and which is going to touch both of them at M and N. So this point is M and this point is N. Now we know that this distance is 5, this is 3 and this is 4. So radius of this bigger circle will be 6 unit. So radius of this larger circle, it is 6 units. Now this is 2 and this is 3. So this C3, it divides origin and 3, 4 in the ratio 3:2. So center of the circle C3 will be at 9/5 and 12/5. So for this third circle, we have center and we also have its radius. Now it says a line through XY intersects C3 at Z and W, and let the common tangent of C1 and C3 be a tangent to parabola x square equals 8 alpha y. Now it also says these two circles, they intersect at capital X and capital Y. So this is your X and this point, it is your Y. Now basically this XY, it is common chord of C1 and C2, and we know that common chord is given by radical axis, which is S1 minus S2. So this equation will be x square minus x minus 3 square plus y square minus y minus 4 square, and that will be 9 minus 16. Now here x square will cancel. We'll get this as 6x minus 9 plus 8y minus 16, and this is minus 7. Equation of xy, it is given by 6x plus 8y. Now this is minus 9 plus 7 minus 2, so there will be minus 18, 0, and we can divide everything with 2. So this equation will be 3x plus 4y minus 9 equals 0. So this line xy, its equation is 3x plus 4y minus 9 equals to 0, and it's going to intersect this third circle at Z and W. Now for this circle C3, we can find this AC3, which is perpendicular distance of this line from center of the circle. So this AC3 will be 3 into, and this center is at 9 by 5 plus 4 into 12 by 5 minus 9 upon under root of a square plus b square, which is 5. Now this is 27 plus 48 minus 45. So there will be 30. 30 by 25, which is simply 6 by 5. So length of AC is 6 by 5. And once we have this AC3, we can find length of AZ, because this radius is 6 units. So this AZ will be under root of 36 minus 36 upon 25. So there will be 6 root 24 upon 5, and ZW is 2 times of AZ. So ZW will be 12, 24 root 6 by 5. Now we also have to find XY. Now for XY, we will find this distance OA, and we know that OA, it will be 0 plus 0, 9. So this is 9 by 5, and this XY will be 2 times under root of this 9 minus 81 by 25. So this is 225 minus 81, 144. So there will be 24 upon 5. Now we can start solving these questions. Now first is the value of 2h plus k. Now h and k, they are center of this C3. So basically h is 9 by 5 and k is 12 by 5. So 2h plus k is 18 plus 12, 30. 30 by 5 is 6. So 2h plus k is 6. So this first, it matches with P. Now second one is length of ZW upon length of XY. Now length of ZW is 24 root 6 by 5, and length of XY is 24 by 5. So this is equal to root 6. So that means this second, it matches with Q. Now third one is area of triangle MZN. Area of triangle MZN, this triangle will be 1 by 2 base into height. So this area, it will be 1 by 2. Now base here is MN, and MN is 12 into AZ. AZ is half of ZW, and that will be 12 root 6 by 5. divided by area of triangle ZMW. Area of triangle ZMW, this triangle, and here this is your base and that's your height. So this area will be this 1 by 2. Base is ZW, which is 24 root 6 by 5 into this AM. Now OA is 9 by 5 and this is 3. So it will be this 9 by 5 plus 3. 15 plus 9 is 24. So it will be this 24 by 5. Now this is 12 root 6 by 5. It will cancel. Now this is 2. So this value is 5 by 4. So this third, it matches with R. Now fourth one, we have to find alpha, and it says a line through XY intersects C3. Let a common tangent of C1 and C3 be tangent to this parabola. Now this is C3 and this is C1. So their common tangent will be this line. Now these C3 and C1, they touch each other internally. So they'll have only one common tangent. Now for this, what we'll do is we'll first find the coordinate of M. Now basically origin is midpoint of M and C3. So basically coordinate of this point M will be simply minus 9 by 5 and minus 12 by 5. And we can also find slope of this line. Now slope of this line is 4 by 3. Then slope of this other line will be minus 3 by 4. So equation of this common tangent will be y plus 12 by 5 and will be equal to minus 3 by 4 into x plus 9 by 5. Now this is 4 into 5 by plus 12, and that will be equal to minus 3 into 5x plus 9. So its equation will be given by 15x plus 20y. Now this is 48 plus 27 plus 75 equals 0, or 3x plus 4y plus 15 equals 0. Now this line, it is tangent to this parabola x square equals 8 alpha y. Now for this parabola, equation of tangent is given by y equals mx minus am square, and a in this case is 2 alpha. So it will be 2 alpha m square. So if we express this equation, then it will be this y equals minus 3 by 4x minus 15 by 4. So if we equate the two equations, we get minus 2 alpha, and m square is 9 by 16, and it will be equal to minus 15 by 4. Now this minus will cancel. Now this is 4, this is 2, and this is 2, and this is 5. So we get 3 alpha is 10, or value of alpha is 10 by 3. So basically this fourth will match with U. Now which of the following is the only correct combination? Second T, 1U, second Q. So this is your option D. And which of the following is the only incorrect? Fourth S, so this A. 3R, 4U, and 1P. So the correct options are B and A. Now here the question is, let O be center of the circle where R is greater than under root 5 by 2. Suppose PQ is a chord of the circle, and equation of line passing through P and Q is 2x plus y equals 5. If the center of circumcircle of triangle OPQ lies on this line x plus 2y equals 4, then the value of R is. So we have this circle with center at origin and radius equals R. And chord of the circle is PQ, whose equation is 2x plus 4y equals 5. And as we can see, its perpendicular distance is 5 upon root 20, which is 2 root 5. So this distance, it is less than r, and therefore they have given r should be greater than under root 5 by 2. Now it says, if circumcircle of triangle OPQ lies on x plus 2y plus 4 equals 0. So circumcircle of this triangle OPQ. So we have this circumcircle of triangle OPQ, and it lies on this line which is parallel to this given line. So it will lie on this line, which is x plus 2y equals 4. Then we have to find the value of r. Now if we join this center with P and Q, this CP is equal to CQ, and this distance from the origin to this line, it will be 4 by under root 5. So this OC is 4 by under root 5, and basically OC is same as CP and CQ. So it is also equal to CP and CQ. Now suppose this point is A. Now OA is 5 upon 2 root 5. So we can find the CA. CA will be 4 root 5 minus 5 upon 2 root 5, and that will be basically 3 upon 2 root 5. Now what we are trying to do is, we are trying to create AP square from these two right angle triangles. So we can write AP square as CP square minus AC square, and will also be equal to OP square minus OA square. Now CP is 4 by root 5, so there will be 16 by 5 minus AC square, and AC is 3 by 2 root 5, so there will be 9 by 4 into 5, and OP square is R square minus OA square is 25 by 20. Now this is plus 16 by 20, and which is 4 by 5, and this is equal to R square. Now R square is simply 4, so value of R is 2, and that is the answer to this question. Now here the question is, consider a triangle whose two sides lie on x-axis and the line x plus y plus 1 equals 0. So we have our coordinate axis, and then we have this line which is x plus y plus 1 equals 0. So this is x plus y plus 1 equals 0. So one of the point of this triangle is intersection of x-axis with this line. So we put y is 0, we'll get x as minus 1. So this point B is minus 1 comma 0. Now it says its orthocenter, it is at 1 comma 1. So orthocenter of this triangle, it is at 1 comma 1. Now one of the side is x-axis, so it's perpendicular. We'll pass through this point H, and they'll give us another point on this triangle, and this is suppose this point A. For this A, x coordinate is 1, and if you put x as 1, we get y as minus 2. So this point A, it is 1 comma minus 2. Now we have to find coordinate of this another point C. Now C will lie on x-axis. So let the coordinate of C be h comma 0. Now CH will be perpendicular to AB. So slope of CH into slope of AB, it should be minus 1. Now slope of CH is 0 minus 1 upon h minus 1 into, and slope of AB is minus 2 upon 2, and this is minus 1. So this minus 1 will cancel, This will cancel. So value of h is 0. So coordinate of this point C will be at origin. So this C is 0, 0. So this triangle ABC will be drawn like this. Now we need to find equation of circle passing through these 3 points. Now let the equation be x square plus y square plus 2gx plus 2fy plus c equals to 0. Now since it passes through origin, value of c is simply 0. And from minus 1, 0, we'll get 1 minus 2g equals 0. So value of g is 1 by 2. And if we put 1, minus 2, we'll get 1 plus 4 plus 2g minus 4f equals 0. Now 2g is 1. So it will be equal to this 6 by 4. So value of f is 3 by 2. So equation of this circle will be x square plus y square plus x plus 3y equals 0. And that's your option B. And this question, it says, let ABC be a triangle with AB equals 1, AC equals 3 and BAC equals pi by 2. If a circle of radius r greater than 0 touches the sides AB and AC and also touches internally the circumcircle of triangle ABC, then the value of r is. What we'll do is, since it is a right angled triangle, we'll take this triangle along axis of coordinate. Now angle A is 90, so this is A, this is B, and this is C. Now suppose A is at origin, B is at 1, 0 and C is at 0, 3. And if we take its circumcircle, and we know that center of the circle will be midpoint of BC. So this center will be 1 by 2 and 3 by 2. And this length of BC is under root 10, which is diameter of the circle. So radius of this circle will be under root 10 by 2. Now it says we need to find radius of a circle which touches these two sides and also this circle. Now we know that any circle which touches both the axes, its center will be r, r. Since in this case we are dealing with first quadrant and its radius will also be r. Now these two circles, they touch each other internally, and if the two circles touch each other internally, then C1, C2, it must be equal to R1 minus R2. So basically C1, C2, it must be equal to R1 minus R2, and R2 in this case is R. Now C1, C2 is under root of R minus 1 by 2 square plus R minus 3 by 2 square, and it will be equal to under root of 10 by 2 minus R. Now we square this, we'll get R square plus 1 by 4 minus R plus R square plus 9 by 4 minus 3R, and this is 10 by 4 plus R square minus under root 10R. Now 1 by 4 plus 9 by 4 is 10 by 4. So this 10 by 4 and 10 by 4 will cancel. R square will also cancel. So we'll get this as R square equals 4 minus under root 10 R. Now R cannot be 0. So from here we'll get the value of R as simply 4 minus under root 10. And 4 minus under root 10 is nearly 0.84. So answer to this question is 0.84. And question number 12, we are given that let G be a circle of radius r which is greater than 0, and G1, G2 and Gn be n circles of equal radius r. Suppose that each of n circles touches the circle externally, and each circle touches its next circle, and Gn touches G1. So we have this circle whose radius is R, and then we have these circles which touch each other, and it will continue up to G1 and Gn. Now if we look at any two circles, this angle, it will be simply 2 pi by n. Now if we look at this triangle, this half angle, it will be simply pi by n. This small radius is r, this is r, and this capital radius is capital R. So from here we can write sine pi by n, it will be equal to r upon r plus r, or we can write r plus r is r cosec pi by n, or we can write r upon r equals cosec pi by n minus 1. So from this figure we have got this relation. Now for this option A, it says if n is 4, then r is greater than r into root 2 minus 1. So what we'll do is we'll put n as 4. Now if we put n as 4, we get r upon r as cosec pi by 4 minus 1, which is root 2 minus 1. So in this case, this r, it should be equal to root 2 minus 1 into r and not greater than that. That means this option A is incorrect. Now for option B, we'll put n as 5. Now if we put n as 5, we'll get r upon r equals cosec pi by 5 minus 1. Now basically pi by 5, it will be greater than pi by 6. Now cosec, it is a decreasing function, so we can write cosec pi by 5, it will be less than cosec pi by 6, and cosec pi by 6 is 2. So from here we can write cosec pi by 5 minus 1, it will be less than 1. So this value will be less than 1. So from here we can write r should be less than r. That means this option B is also incorrect. Now for this option C, we'll take n as 8. If we take n as 8, we can write r upon r equals cosec pi by 8 minus 1. Now pi by 8 is less than pi by 4. Cosec pi by 8 will be greater than cosec pi by 4, which is root 2. So cosec pi by 8 minus 1 will be greater than root 2 minus 1. So it will be greater than root 2 minus 1. So in this case, for n equals 8, r should be greater than root 2 minus 1 into r. That means this option C is correct. So this option C is correct. R is greater than root 2 minus 1 into r. And for n equals 12, we can write r upon r as cosec pi by 12 minus 1. So this is cosec 15 degrees minus 1. Now cosec 15 degrees is 2 root 2 root 3 minus 1 and then minus 1. Now we'll rationalize it. So it will be this root 2 into root 3 plus 1 minus 1, and it will be less than root 2 into root 3 plus 1. So from here we can write r should be less than root 2 into root 3 plus 1 into r. That means this option D is also correct. So the only correct options are C and D. Now here the question is, a circle of radius r passing through origin cuts the axis at A and B. The locus of root of perpendicular from O to AB is this value, then find the value of lambda. So we have this circle which passes through origin and which intersects axis at A and B. And radius of this circle is R. Now it says, if the locus of foot of perpendicular from O to AB is this value, find the value of lambda. Now we'll join this AB and we have to find locus of foot of perpendicular on this AB. So let it be this point P and let this point be alpha beta. Now what we'll do is we'll first find equation of this line AB and then we'll find these points A and B. So slope of OP, it is beta upon alpha. Then slope of AB, it will be minus alpha upon beta. Now once we have point and slope, we can write equation of AB. So we'll write equation of AB as y minus beta equals minus alpha upon beta x minus alpha. So we'll get this equation as alpha x plus beta y and it will be equal to alpha square plus beta square. Now we'll find their intercept. So this point A, it will be alpha square plus beta square upon alpha comma 0 and coordinate of this point B will be 0 comma alpha square plus beta square upon beta. Now this AB is diameter of the circle. So basically this AB, it is equal to 2R and if we square it, we can write AB square will be equal to 4R square. Now AB square is alpha square plus beta square whole square upon 1 upon alpha square plus 1 upon beta square and that will be equal to 4R square. Now we'll replace alpha with x and beta with y. So this required locus will be x square plus y square whole square into 1 upon x square plus 1 upon y square and will be equal to 4R square. Now we compare it with lambda R square. That means value of lambda is 4 and that's your option C. Now here the question is, it is given that two circles, both of which pass through the points 0 comma A and 0 comma minus A and touch the line y equals mx plus c will intersect orthogonally if c square equals a square into lambda plus m square. We have to find the value of lambda. Now basically both the points, they lie on y-axis. One of them is 0 comma a and the other one is 0 comma minus a and equation of y-axis is x equal to 0. Now we find family of all the circles which passes through these two fixed points and it is given by x square plus y minus a into y plus a plus lambda x equals 0. So this equation will be x square plus y square plus lambda x minus a square equals 0. So this is the equation of family of all the circles which pass through these two fixed points. Now center of the circle is at minus lambda by 2 comma 0 and its radius is under root of lambda square by 4 plus a square. Now since this circle, it touches this line mx minus y plus c equals 0, that means perpendicular distance from center must be equal to its radius. So we'll get minus m lambda by 2 plus c upon under root of 1 plus m square and it will be equal to under root of lambda square plus 4a square by 4. Now if we square it, we'll get this as minus m lambda plus 2c whole square. Now this 2 and 2 will cancel and it will be this 1 plus m square into lambda square plus 4a square. Now we can write this as m square lambda square plus 4c square minus 4 mc lambda, and that will be equal to lambda square plus lambda square m square plus 4a square into 1 plus m square. Now here m square lambda square will cancel. Now we can write this as a quadratic equation in lambda. So there will be lambda square plus 4 mc lambda and plus 4 a square 1 plus m square minus 4c square equals 0. Now we need two such circles. So the two parameters are lambda 1 and lambda 2, and the value of and product of roots, which is lambda 1 into lambda 2, it is given by c by a. So there will be 4 a square 1 plus m square minus 4c square upon 1. So this is our first equation. Now it says both the circles, they intersect orthogonally. The equation of two circles is x square plus y square plus lambda 1x minus a square equals 0 and x square plus y square plus lambda 2x minus a square equals to 0. Now these two circles, they intersect orthogonally. So that means 2 times g1 g2, and g1 is lambda 1 by 2 and g2 is lambda 2 by 2 minus f1 f2, that is equal to c1 plus c2. So that will be equal to minus 2a square. Now 2 and 2 will cancel. So we'll get lambda 1 into lambda 2 as minus 4a square. Now we'll put the value of lambda 1 into lambda 2. So there will be this 4a square 1 plus m square minus 4c square, and that will be equal to 4a square. Now this 4 and 4 will cancel. We'll get this as c square equals a square, and this is 2 plus m square. Now we compare it with the given condition. That means value of lambda, it must be 2. So answer to this question is value of lambda is 2, and that's your option B. Now here the question is, let S be the sum of this decreasing infinite sequence of shaded areas, then the value of greatest function of S is. Now in the question it is already given that this angle is 30 degrees. Then we can write, then for this triangle OAX we can write sine 30, and sine 30 is R1, which is 1 upon OX. Now sine 30 is 1 by 2, so value of OX is simply 2. Now this value is 2, this is 1, and this is R2. So basically this O dash X, it will be 2 minus 1 minus R2. So there will be 1 minus R2, and if we write sine theta for this triangle O dash A dash X, then we can write sine 30. It will be R2 upon 1 minus R2, and this is equal to 1 by 2. Now simplifying this, we get R2 as 1 by 3. And it's a very standard result that circles touching each other and with a common tangent, their radius, they are in GP. So all these radiuses, they are in GP with common ratio 1 by 3, and first term is 1. Now we will find area of this shaded region. Now for this, we'll find area of this triangle OAX. So area of triangle OAX, it is given by, now this is 1 and this is 2. So this is root 3. So this area, it will be half base into altitude, and that will be root 3 by 2. Now we'll find area of all these circles. Now this area is, say, delta 1. Now this first area, it is simply area of this sector. So it will be this half r square theta. So it will be this 1 by 2, 1 square, and theta in this case is pi by 3 plus. Now all these circles, they are semicircles. So basically it will be 1 by 2 into pi r square. So there will be pi and then r square. And here r square is 1 by 3 square, 1 by 3 to the power 4 up to infinite. Now we simplify this, we'll get this as 1 by 2 and this is pi by 3. This is pi and this is sum of GP. So this is a upon 1 minus r. So we'll get this as 1 by 2 and this is pi by 3 plus pi by 8. So it'll be 11 pi by 48. Now area of this shaded region is area of this triangle minus area of circles. So this required area will be root 3 by 2 minus 11 pi by 48. And this value is nearly 0.146. So that's your S. Now it says we have to find greatest integral function part of S. Now in this case, greatest function of S will be simply 0. So answer to this question is this option A. Now the question is 3 circles with radius R1, R2 and R3 touch each other externally and they have a common tangent. Then we have to find this value. So we have 3 circles which touch each other externally and they also have a common tangent. Now R1 is the smallest, so suppose this is R1, this is R2 and this is R3. We have to find this condition. Now we can solve this question using either Descartes' theorem of crossing circles or using length of direct common tangent. Now we know that length of direct common tangent between 2 touching circles externally, it is given by 2 under root R1, R2. So suppose we have these points A, B and C. Now for these 2 circles, we can write AB as twice under root R1, R3. BC is 2 under root R1, R2 and AC is 2 under root R2, R3. Now AB plus BC is equal to AC. So we'll get 2 under root R1, R3 plus 2 under root R1, R2. It is equal to 2 under root R2, R3. Now this 2 will cancel and we'll divide everything with R1, R3. So we'll get under root of R1 upon R2 plus under root of R1 upon R3 will be equal to 1, and that's your option A. And this also becomes a standard result where we can write under root R1 and this is under root R2 plus under root R3 upon under root R2, R3 equals 1. So radius of this smaller circle R1, it will be R2, R3 upon under root of R2 plus under root of R3 whole square. Now here the questions, we are given 2 lines L1 and L2 and they are parallel to each other. So we have 2 lines. One of the line is 2x plus 3y plus p minus 3 equals 0 and the other one is 2x plus 3y plus p minus 3 equals 0. And we have this circle which is x square plus y square plus 6x plus 10y plus 30 equals 0. If it is given that at least one of the line is a chord of the circle C, then the probability that both are chords of C is. Now first we have to find the condition that at least one of the line is a chord of C. Now center of this circle, it is at minus 3 comma minus 5, and its radius is under root of 9 plus 25 minus 30, and which is 2. Now first we'll take this condition that 2x plus 3y plus p minus 3 equals to 0 is a chord of a circle. Now it'll be chord of the circle if perpendicular distance from the center is less than r. So then perpendicular distance from the center will be this minus 6 minus 15 plus p minus 3 upon, now this is under root 9 plus 14, 13. So there will be under root 13, and it should be less than 2. So we'll get this condition that mod of p minus 24, it is less than 2 root 13, or this p, it lies between 24 minus 2 root 13 to 24 plus 2 root 13. Now for the second one, the only difference is we'll have p plus 3 here, and if we have p plus 3 here, we'll get this as p minus 18. So the second condition is if this line 2x plus 3y plus p plus 3 equals to 0 is a chord of this circle, then we'll get mod of p minus 18 will be less than 2 root 13. So basically the condition will be p should lie between 18 minus 2 root 13 to 18 plus 2 root 13. Now we draw all these solutions on a number line. Then first we have 18 minus 2 root 13, and then there will be this 18 plus 2 root 13, and the second line will be chord of this circle if value of p lies between these two values. And next we have this 24 minus 2 root 13. Now root 13 is 3 point something. So this is 6 point something. 24 minus 6 point something is 17 point something, which is going to be here. So this point 24 minus 2 root 13 and 24 plus 2 root 13 will be here, and this second line will be chord of this circle if it lies between these two values. Now we need to find this probability that both of them, they are chord of the circle when it is given that at least one of them is chord of the circle. Now it says p can only take integral values, so we have to work these values out. Nearly 25.2, and this value is nearly 31.2, and this value is nearly 10.8, and this is nearly 16.8. Now the integral values of p in this set S1, they are 11, 12 up to 25. So the values of p for which this first line, it is a chord of the circle, is this set S1 from 11 to 25, and the set that the second line is a chord of the circle will be from 17 to 31. Now intersection of S1 and S2 is values where both the lines, they are chord of the circle, and these values, they'll start from 17 up to 25. So there are 9 values, and S1 union S2 will be values from 11 to 31, and here we have 21 values. So this required probability will be variable values 9 upon total values 21, which is 3 by 7, and that's your option B. Now here the question is, consider a family of circles passing through intersection point of these two lines and having its center on the acute angle bisectors of the given line. Show that the common chord of each member of the family and the circle are concurrent, and if the point of concurrency is a comma b, find the value of a plus b. Now both the lines, they pass through the point 1 comma 1. These two lines, they intersect at 1 comma 1. So this is your point, say a, 1 comma 1. Now for the first line, slope is 1 by root 3. And for the second line, slope is root 3. So one of them is going to make an angle of 30 degrees and the other one is going to make an angle of 60 degrees. Now center of the circle, it lies on acute angle bisector of these two lines. Now we know that this angle is 30 and this is 60. So this angle will be 45. So slope of this line is 45. So equation of this line, it will be y minus 1 equals 1, x minus 1. So center of the circle will lie on y equals x line. Now suppose center of the circle is at h, comma h, then equation of this circle will be x minus h square plus y minus h square, and it is equal to r square. And r square is distance from the center to this point 1 comma 1. So it will be this h minus 1 square plus h minus 1 square. Now we simplify this, we'll get this as x square plus y square minus 2hx minus 2hy. Now h square will cancel and here we'll get this as plus 4h minus 2 equals 0. We can add this as x square plus y square minus 2 and then minus 2h x plus y minus 2 equals 0. Now equation of this other given circle is x square plus y square plus 4x minus 6y plus 5 equals to 0, and equation of common chord, it is given by radical axis of the two circles. So we'll subtract this first equation from second. So this x square y square will cancel. So we'll get this as 4x minus 6y plus 7 and then plus 2h x plus y minus 2 equals 0. So basically this equation is L1 plus 2h, L2 equals to 0, where h is a parameter. Now it represents family of all the lines which pass through point of intersection of L1 and L2. So that fixed point is intersection of these two lines. So we have to find point of intersection of 4x minus 6y plus 7 equals 0 and x plus y minus 2 equals 0. Now we'll multiply the second equation with 6. So it will be this 6, 6 and 12. And if we add them, we'll get this as 10x equals 5. So value of x is 1 by 2. And we put x as 1 by 2, we'll get y as 3 by 2. So basically that fixed point is 1 by 2, comma 3 by 2. Now that's your a and this is your b. We need to find the value of a plus b. Now the value of a plus b is 4 by 2, which is simply 2, and that's your option C. Now here the question is, consider two fixed circles x square plus y square plus 4 mod x plus 3 equals 0. center is at plus minus 2 comma 0 and radius is 1 unit. So we have two circles with centers at minus 2 comma 0 and plus 2 comma 0 and radius equals 1 unit. Now it says a triangle ABC is initially located so that its vertices have the following positions. Now C is at this point, minus 2 comma 2 plus 2 root 3, and this B, it is at 2 comma 2 plus 2 root 3. Now basically it is a line which is parallel to x-axis. And then point A, it is at 0 comma 2. That's your y-axis. And we have this triangle. Now slope of this line, it is 2 root 3 upon 2 root 3. So this angle is 60. And here this slope, it is minus root 3 120. So this angle, it is 60 degrees. So basically it's an equilateral triangle. Now it says it starts translating downwards perpendicular to the x-axis and stops when its edges hit the circle AB at the point P1 and AC at point P2. So this triangle, it starts coming down till it becomes something like this. We'll redraw this circle like this. Now this point is, say, P1 and this point is your P2. This is A and this is B. Now we have to find the ratio in which P1 divides AB. Now we'll drop this perpendicular here, and this is 90. We know that this angle is 60, so this angle will be 30. And radius of this circle is 1 unit. So if we write P1B will be 1 cot 30, and that will be simply root 3. Now length of AB, it is 4 units using distance formula. Then length of P1A is 4 minus root 3. Now we have to find the ratio of P1A upon P1B. So we have to find P1A upon P1B. Now this is 4 minus root 3 upon, now P1B is root 3. So answer to this question is 4 minus root 3 upon root 3, and that's your option B. Now here the question is, find the locus of midpoints of all chords of the circle x square plus y square minus a square which pass through fixed point h comma k. Now this is locus problem. We have to find locus of midpoint. Now let this point be alpha beta. Now if midpoint is given, we know that equation of chord is given by t equals s1. So this equation will be alpha x plus beta y minus a square will be equal to alpha square plus beta square minus a square. Now this a square will cancel. Now this chord, it will pass through this point h comma k. So we get alpha h plus beta k and will be equal to alpha square plus beta square. In the end, we'll replace alpha with x and beta with y. So this required locus will be this circle x square plus y square minus hx minus ky equals 0. So that's your first question. Now the second question is, find the locus of middle point of chords of the circle which subtends a right angle at the point c comma 0. So we have this circle. And then we have a chord say AB, and we will find locus of midpoint of this chord. So let it be this alpha beta, and then it says this chord, it subtends right angle at this point C comma 0. So we have a point, say C comma 0, and this chord, it subtends an angle 90 degrees here. Now let us suppose coordinate of B is A cos theta and A sin theta, and at this point AB, H comma K. Now since its midpoint is alpha beta, we can write alpha as H plus A cos theta by 2 and beta as K plus A sin theta by 2. So from here we write coordinate of this point A as 2 alpha minus A cos theta and 2 beta minus A sin theta. Now this point A, allow this circle, so we get 2 alpha minus A cos theta square plus 2 beta minus A sin theta whole square will be equal to A square, allow this circle, so we'll get 4 alpha square plus 4 beta square minus 4 alpha A cos theta minus 4 beta A sin theta, and here A square will cancel. So we'll get this as equal to 0. So the condition that we'll get here is alpha square plus beta square will be equal to A alpha cos theta plus beta sin theta, and that's our first equation. Now the second condition that is given is AP subtends an angle 90 degrees at this point, say P. Then product of slope is minus 1. So we can write K upon H minus C into A sin theta upon A cos theta minus C. It is minus 1. Now we know the value of H and K. So it will be this 2 beta minus A sin theta into A sin theta upon H minus C. So it will be 2 alpha minus A cos theta minus C into A cos theta minus C, and this is equal to minus 1. Now we simplify this, we can write this as, we'll take this minus sign here, so we'll write minus 2 beta into A sin theta plus A square sin square theta, and here it will be 2 alpha A cos theta minus 2 alpha C minus A square cos square theta plus AC cos theta minus AC cos theta plus C square. Now AC cos theta will cancel, and cos square theta plus sin square theta will be 1. So we can write 2 alpha A cos theta plus 2 beta A sin theta. Now cos square theta plus sin square theta will be 1. So we'll get this as A square plus 2 alpha C minus C square. Now alpha A cos theta plus beta A sin theta, it is alpha square plus beta square. So we'll get this as 2 alpha square plus beta square equals A square plus 2 alpha C minus C square. So this required locus is 2 x square plus y square minus 2cx plus c square minus a square equals 0, and that is the answer to this question. Now here the first question is, whatever with the value of alpha, prove that locus of intersection of straight line is a circle. So we have two lines, x cos alpha plus y sin alpha equals a and x sin alpha minus y cos alpha equals b. Now here alpha is a parameter and point of intersection is suppose xy itself. I don't want to change it in hk and then change it again to xy. Now we have to eliminate alpha. So what we'll do is we'll simply square and add the two equations. So here it is x square cos square alpha plus y square sin square alpha plus 2xy cos alpha sin alpha, and that will be equal to a square, and here will be this x square sin square alpha plus y square cos square alpha minus 2xy sin alpha cos alpha, and that will be b square. Now if we add them, this 2xy term will cancel. Now cos square theta plus sin square theta is 1, so we'll get this as x square plus y square equals a square plus b square, and that's your required locus, which is a circle. The locus of a point which is such that tangents from it to the two given concentric circles are inversely as their radius is a concentric circle, the square of whose radius is equal to sum of squares of radius of two given circles. So we have two concentric circles, say, which are x square plus y square equals a square and x square plus y square equals b square. Now it says tangents are inversely proportional to their radius. So that means under root s1 upon under root s1 dash will be equal to b upon a, or simply s1 upon s1 dash is equal to b square upon a square. Now s1 is alpha square plus beta square minus a square, where this point p is say alpha beta, and s1 dash is alpha square plus beta square minus b square, and that will be equal to b square upon a square. Now we simplify this, we can write a square minus b square alpha square plus beta square will be equal to a to the power 4 minus b to the power 4. Now a square minus b square will cancel. So this required locus will be alpha square plus beta square equals a square plus b square, which is this circle. X square plus y square equals a square plus b square, and center of the circle is again at 0, 0. So it will be concentric to the two given circles, and its radius square is a square plus b square, which is sum of squares of radius of the given circles, and which is what we need to prove in this question. Now here the question is, prove that a common tangent to the two circles of a coaxial system. Now it says, prove that a common tangent to two circles of a coaxial system subtends a right angle at either limiting points of the system. Now suppose system of coaxial circles is given by x square plus y square plus 2gx plus c equals to 0, and it represents system of all coaxial circles for which radical axis is y-axis. Now suppose we have two circles in this system. And we have their common tangent, and suppose these points of contacts are A and B. Now we also have to find limiting points. Now for this, radius of this circle is under root g square minus c, and for limit points radius must be 0, so we get gs plus or minus under root c. So the limit points are plus minus under root c comma 0. Now suppose center of the circles are at minus g1 comma 0 and minus g2 comma 0. Now let us take any one limit point, say this one, under root c comma 0. Now we have to prove that this tangent it subtends right angle at this limit point. Now suppose this point is P and it is 0 comma K. Now we can write PA square, which is S1, and it will be this K square plus C, and it will also be equal to PB square. So basically PA is equal to PB. And if we find this CP, then CP square is also C plus K square. So if we draw a circle through this point P with AB as diameter, it will pass through this point C, and therefore this angle, it is 90 degrees. So from here we can say this angle ACB, this is 90 degrees, and this is what we need to prove in this question. Now here the question is, prove that center of similitude of two circles, that is locus of the point at which two circles subtends the same angle, is a coaxial circle. Now we have two circles which are x square plus y square minus 2kx plus delta equals to 0, and x square plus y square minus 2k dash x plus delta equals to 0. Now here center is k comma 0 and radius is under root of k square minus delta, and here center is k dash comma 0 and radius is under root of k dash square minus delta. Now both the circles, they subtend equal angle at this point P. We have to find locus of this point P. Now suppose this point is alpha beta. Now if this is theta, then this is theta by 2, and here also this is theta by 2. Now this is R1 and this is PA, and this is R2 and this is PB. Then we can write tan theta by 2 as R1 upon PA, and they'll be equal to R2 upon PB. So we can write PA upon PB will be equal to R1 upon R2. Now PA is length of tangent, so it will be this under root of alpha square plus beta square minus 2k alpha plus delta, and here will be this under root of alpha square plus beta square minus 2 k dash alpha plus delta, and will be equal to under root of k square minus delta upon k dash square minus delta. And we square it, we can write this as alpha square plus beta square minus 2k alpha plus delta upon alpha square plus beta square minus 2 k dash alpha plus delta, and will be equal to k square minus delta upon k dash square minus delta. Now we know that if a upon b equals c upon d, then a upon a minus b will be equal to c upon c minus d. So we can write alpha square plus beta square minus 2k alpha plus delta upon, and if we subtract this, we can write minus 2 alpha k minus k dash, and this is equal to k square minus delta, and it is k square minus k dash square. Now k minus k dash will cancel, so we'll get alpha square plus beta square minus 2k alpha plus delta upon minus 2 alpha, and that will be equal to k square minus delta upon k plus k dash. Now we can rearrange this as alpha square plus beta square, and then minus 2 alpha, and this is k here, and then it will be k square minus delta upon k plus k dash, and plus delta equals 0. Now it will be this alpha square plus beta square minus 2 alpha, Now here k square will cancel, so it will be this k dash plus delta upon k plus k dash plus delta equals to 0. So locus of this point P will be x square plus y square minus 2 k dash plus delta upon k plus k dash x plus delta equals to 0, and which is what we need to prove in this question. Now the question is, find the equation of circle cutting the three circles orthogonally. Now we know that center of the circle which cuts three circles orthogonally is going to lie on a radical center. So we have to find radical center of three circles, for which we have to find radical axis of two circles. Now from first two we can write x minus c square plus y square minus a square minus x square plus y square minus a square equals 0. Now here a square and y square will cancel, x square will also cancel, so we get c square minus 2cx equals 0. Then the value of x is c by 2. Now from first and third we can write x square plus y minus b square minus a square minus x square plus y square minus a square equals 0. We'll get this as b square minus 2by equals 0, or y equals b by 2. So radical center of these three circles will be at c by 2 and b by 2, which is the center of circle which cuts the three circle orthogonally. Now radius of this circle is equal to length of tangent from this center to any circles. So this radius will be under root of, now we'll put it here, so it will be the c square by 4 plus b square by 4 minus a square. So equation of this circle will be x minus c by 2 square plus y minus b by 2 square, and that will be equal to c square by 4 plus b square by 4 minus a square. Now if we simplify this, we'll get this equation as x square plus y square minus cx minus by plus a square equals 0. Now here the question is three concentric circles of which biggest is x square plus y square equals 1. So we have three concentric circles. Center at origin, and radius of this bigger circle is 1, and have their radius in AP. So suppose this is 1, radius for this is suppose 1 minus d, and radius for this circle is 1 minus 2d, where d is greater than 0. It says if the line y equals x plus 1 cuts all the circle in real and distinct points, the interval in which common difference of AP will lie is. Now a line is going to intersect the three circles if it intersects this smaller circle. So perpendicular distance from the center must be less than its radius. Now perpendicular distance from the center to this line will be 0 minus 0 plus 1 upon root 2. It should be less than 1 minus 2d, or we'll write 2d is less than 1 minus 1 by root 2, or d is less than root 2 minus 1 upon 2 root 2. We can also write this as 2 minus root 2 upon 4. Now this common difference, it should be greater than 0 and it should be less than this value. So this d, it belongs to the interval 0 comma 2 minus root 2 upon 4, and that's your option C. Now here the question is, a circle of radius unity is centered at origin. So we have this circle whose center is at origin and radius is 1 unit. It says two particles start moving at the same time from the point 1, 0. So we have this point, say A, which is 1, 0, and move around the circles in opposite direction. One of the particle moves counterclockwise with speed v, So one particle, it is going to move with the speed v, and the other, it moves clockwise with the speed 3v. Now, after leaving 1, 0, the two particles first meet at point P and continue until they meet next at point Q, the coordinate of point QR. Now, since their velocities are in the ratio 1:3, so if this first particle is going to cover theta, this second particle is going to cover 3 theta. So when this first particle, it has moved pi by 2, this second particle, it would have moved 3 pi by 2 in the clockwise direction. So at first they are going to meet at this point P, and this is 0, 1. Now hereafter again they'll move. So again this first particle, it is going to cover pi by 2, and the second particle, it is going to cover 3 pi by 2. So next they are going to meet at this point, which is minus 1, 0, and that's your point Q. So coordinate of this point Q is minus 1, 0, and that's your option D. Now the question is, if A is maximum of this value and B is maximum of this value, where xy satisfy this equation. So basically xy, they lie on the circle whose center is at minus 4, 5, and whose radius is under root of 16 plus 25 is 40, which is simply 9. And basically if we look at this, it is square of distance. So basically A is square of maximum distance of this point minus 2, 3 from the circle, and B is square of minimum distance. Now that's your center C, and this is, suppose this point, say P. Now if we find CP, this CP is under root of 4 plus 4, which is simply 2 root 2. So that's your value D. Now its minimum distance, say small m, there'll be this R minus D, and R minus D is 9 minus 2 root 2, and its maximum distance m will be 9 plus D, which is 9 plus 2 root 2. Now basically A and B are squares of this distance. So A will be 9 plus 2 root 2 square, and B will be 9 minus 2 root 2 square. So this A is 81 plus 8, 89 plus 36 root 2, and B is 89 minus 36 root 2. Now if we find A plus B, then A plus B will be 178. That means option B is correct, and A minus B will be 72 root 2, and that's your option D. So the correct options are B and D. Now here the questions. The locus of point of intersection of tangents to this circle at the extremities of the chord of the circle which touches this other circle is. Now since this is a locus problem, first thing is identify the point. So we'll let this point is P, alpha, beta. Now from this point, tangents are drawn to this circle, and we have this chord of contact, and we know that chord of contact is given by t equals 0. So equation of chord of contact, there will be alpha x plus beta y minus a square equals to 0. That says this chord, it is tangent to this circle whose center is at a, 0, and radius is a. So perpendicular distance from center must be equal to its radius. So we'll get alpha a minus a square upon under root of alpha square plus beta square, and they'll be equal to a. Now this a will cancel. If we square it, we get alpha square plus beta square equals alpha minus a whole square or it will be this beta square equals a square minus 2a alpha. So this required locus, it will be y square equals, we'll take a common, and there will be this a minus 2x, and that's your option A. And since it is a multiple choice question, we can substitute xy here also. So it will be this x square plus y square, and this is x minus a whole square. That means the correct options are A and C. Now here the questions. Let each of the circles touch the other two, and P1, P2, P3 be the points of contacts of S1 and S2, S2 and S3, and S3 and S1 respectively. And let C1, C2, C3 be the centers of S1, S2, S3. Now C1 is 0, minus 2, and its radius is root 5. C2 is minus 3, minus 1 by 2, and its radius is 9 plus 1 by 4 minus 8. So 1 plus 1 by 4 is root 5 by 4. So R2 is under root 5 by 2, and C3 is 2, 2, and its radius is 37 plus 8 under root 45, which is 3 root 5. So this R3 is 3 root 5. Now this C3, it is a bigger circle. And the other two circles, they touch C3 internally and they touch each other externally. So this is C3. And then we have C1 and C2. So this is C1 and this is C2. Now S1, S2 did touch at P1. So this point is P1, S2, S3 at P2, and this point is P3. So we have these two triangles, C1, C2, C3 and P1, P2, P3. Now first we have to find coordinate of P1. Now P1 is point of contact of these two circles. Now C1 is 0, minus 2 and C2 is minus 3, minus 1 by 2, and this P1, it divides C1, C2 in the ratio R1 is to R2 internally. So it'll divide them in the ratio 2 is to 1. Now this is minus 6 by 3, minus 2, and here will be this minus 1, minus 2, minus 1. So coordinate of P1 is minus 2, minus 1, and that's your option D. Now the same way we can find P2 and P3. Now C3 is 2, 2, C2 is minus 3, minus 1 by 2, and this point P2, it divides it in the ratio R3 upon R2 externally. So we divide it in the ratio 6 is to 1 externally. Now this is minus 18, minus 2, minus 20, minus 20 upon 5 is minus 4. And here will be this minus 3, minus 2, minus 5, minus 5 upon 5 is minus 1. So this point P2 is minus 4, minus 1. And we can also find this P3. Now P3 is going to divide C3, C1 in the ratio C3 upon C1, which is 3 is to 1 externally. Now this is 2, 2, and this is 0, minus 2. So it will be 3 minus 2 upon 2. So this is minus 1. And here it is minus 6 minus 2. Minus 8 minus 8 upon 2 is minus 4. So this point P3 is minus 1 comma minus 4. So now we have coordinate of all the 3 points. So this P1 is minus 2 comma minus 1. Now it says ratio of areas of these two triangles is. Now area of triangle formed by C1, C2, C3 is suppose delta 1. So it will be this 1 by 2, 0, minus 2, 1, minus 3, minus 1 by 2, 1, and then 2, 2, and 1. So this area will be 1 by 2, and then 2 into minus 3, minus 2, minus 5, plus 1, and here will be this minus 6, plus 1. So it will be minus 10, minus 5, minus 15 by 2, and we take this area positive, so it will be 15 by 2 square units. Now we will find area of P1, P2, P3, which is say delta 2. And this area will be this 1 by 2, and this is minus 2, minus 1, 1, minus 4, minus 1, 1, and then minus 1, minus 4, 1. Now if we add these two rows, we'll get this 0, 0, and minus 3. So it will be this minus 3 by 2, and this is 2 minus 4 minus 2. So this area will be simply 3. Now we have to find ratio of these areas. Delta 2 upon delta 1. Now delta 2 is 3 and delta 1 is 15 by 2. So this ratio, it is 2 by 5. And that's your option B. And it says P2 and P3 are image of each other with respect to line. Now we know that P2 is minus 4 comma minus 1 and P3 is minus 1 comma minus 4. So basically here we have interchanged x and y, and we know that we get it by reflecting about this line y equals to x. So this third option, it is this option C. Now here the questions. Let A and B be 2 points and C be a given circle. The chords in which this circle C cuts the member of family S of circle passing through A and B are concurrent at this point. Now first we have to find equation of family of circles passing through these 2 points. Now we know that this family S equal to 0, it is given by x minus 3 into x minus 6 plus y minus 7 into y minus 5 plus lambda xy1 371 and 651 equals to 0. So this equation will be x square plus y square minus 9x minus 12y 53 plus lambda, and this is 2x plus 3y minus 27 equals 0. So this is the equation of family of circles passing through 2 given points. Now it says the chord in which this circle cuts this family. So we have to find the equation of common chord, and we know that equation of common chord is given by radical axis. So this equation will be this S minus C equals 0. So if we subtract it, so we get x square plus y square minus 4x minus 6y minus 3 equals to 0, and it will be this minus minus plus plus and plus x square y square will cancel. So we'll get this as minus 5x minus 6y plus 56 plus lambda 2x plus 3y minus 27 equals to 0, which is L1 plus lambda L2 equals to 0. which is family of lines passing through point of intersection of L1 and L2. So all these lines, they'll be concurrent at point of intersection of these two lines. Now we can write this line as minus 5x minus 6y plus 56 equals 0. And here we multiply everything with 2. So we get 4x plus 6y minus 54 equals 0. Now if we add them, we'll get minus x plus 2 equals to 0. So value of x is 2. And if we put x as 2, it'll be minus 10, 46. 46 upon 6 is 23 by 3. So coordinate of y is 23 by 3. So answer to this first question is this option B, 2, 23 by 3. That says equation of member of family of circles S that bisect the circumference of C. Now, if a circle bisects the circumference of another circle, then basically their common chord will pass through center of the circle. Now we know that this is your equation of common chord. Now since it bisects this given circle, this common chord will pass through center of the circle, which is at 2, 3. So we'll put x as 2 and y as 3 to find the value of lambda. So if we put x as 2 and y as 3, we'll get minus 10 minus 18 plus 56 plus lambda 4 plus 9 minus 27 equals 0. Now this is 28 and plus lambda, and this is minus 14 equals 0. That means value of lambda is 2. So we put lambda as 2. We get equation of this circle as x square plus y square minus 9x minus 12y plus 53 plus 4x plus 6y minus 54 equals 0, or it will be this x square plus y square minus 5x minus 6y minus 1 equals 0. So it will be x square plus y square minus 5x minus 6y minus 1 equals to 0, and that's your option C. And this third question is, if O is the origin and P is center of C, then absolute value of difference of squares of lengths of tangents from A and B to the circle is equal to what? So we have this circle. C. Now center of the circle is at P, and we have 2 points, say A and B. Now this is tangent drawn from A, and that is tangent drawn from B. Now suppose this point is Q and this is R. Now this is say L1 and this is L2. Now we know that AP square, it is equal to R square plus L1 square, and the same way we can write BP square as R square plus L2 square. Now we subtract them, we can write AP square minus BP square mod will be equal to mod of L1 square minus L2 square. Now L1 square minus L2 square is absolute value of difference of squares of length of tangent, which we need to find in this question, and it is equal to mod of AP square minus BP square. That means answer to this third question is this option C. Now here the question is, let L1, L2 and L3 be the lengths of tangents drawn from the point to the circles respectively, and if we are given L1 to the power 4 equals L2 L3 square plus 16, then locus of P are the curves C1, which is a straight line, and C2, which is a circle. So first we'll simplify this. Now suppose this point P is alpha beta, then we know that L1 square, it will be alpha square plus beta square minus 4. L2 square will be alpha square plus beta square minus 4 alpha, and L3 square will be alpha square plus beta square minus 4 beta. Now we are given that L1 to the power 4, that means alpha square plus beta square minus 4 whole square, it is equal to alpha square plus beta square minus 4 alpha into alpha square plus beta square minus 4 beta plus 16. Now we'll take this as first term and minus 4 as second term. We can write this as alpha square plus beta square whole square plus 16 minus 8 alpha square plus beta square, and here also we'll take this as one term, so it will be this alpha square plus beta square whole square minus 4 alpha plus beta into alpha square plus beta square, and then plus 16 alpha beta plus 16. Now here alpha square plus beta square will cancel and this 16 will also cancel. Now we'll take 8 alpha plus beta whole square on the right hand side, then we can write this is 8 alpha plus beta whole square minus 4 alpha plus beta into alpha square plus beta square equals 0, and here we'll take 4 common, then we can write alpha plus beta into 2 alpha plus 2 beta minus alpha square minus beta square equals to 0. So the required locus, it is either this straight line x plus y equals to 0, which is given as this curve C1, or this circle C2, which is x square plus y square minus 2x minus 2y equals 0. Now this first question is circumcenter of the triangle formed by C1 and other two lines which are at an angle of 45 degrees with C1 and tangent to C2 is. So we have this circle whose center is at 1, 1 and radius is √2. So it will be this circle passing through origin, center at 1, 1. And we also have this line x plus y equals 0. If we look at equation of tangent to this circle at 0, 0, it will be this 0x plus 0y minus 2 x plus 0 upon 2 and minus 2 y plus 0 upon 2 equals 0. We'll get this equation as x plus y equals to 0. So basically this C1, it is tangent to this circle at origin. So we have this line which is C1 and this equation is x plus y equals 0, and here this angle is 45 degrees. Now the lines which makes an angle 45 degrees with C1, there will be lines which are parallel to x-axis and y-axis. So we'll have these two lines. So we are talking about this triangle. Now suppose this is A, B, C. Now this angle A, it is 90 degrees. Then basically it is midpoint of BC. So this is midpoint of BC, which is circumcenter of this triangle ABC. And clearly midpoint of BC is at origin. So circumcenter of this triangle ABC, it is origin, and that's your option B. We can work this out also. Now we know that this is 45. This is 45. Now equation of this line is x equals 1 plus √2, and equation of this line is y equals 1 plus √2. So coordinate of this point A is 1 plus √2 and 1 plus √2. Now for this line, if we put x as 1 plus √2, we'll get y as minus 1 plus √2. So it will be 1 plus √2 comma minus 1 plus √2, and here we know y is 1 plus √2, and we put y as 1 plus √2, x is minus 1 plus root 2. And if we find its midpoint, it'll be at origin. So, which is again same as this option B. Now, this second question is, if S1, S2, and S3 are three circles congruent to C2 and touch both C1 and C2, then area of triangle formed by joining centers of S1, S2, and S3 is. So now basically we have C1 and C2, and it says we have three circles which are congruent to this C1 and which touches both C1 and C2. So one of the circle will be drawn like this, and since it is congruent, it will have same radius, and there's a circle, it will be drawn like this, and we have this third circle which should be drawn like this. And suppose their centers are S1, S2, and S3. Now since these circles, they have same radius, we can join line joining these centers. And this is a perpendicular. Now this point is suppose P. Then we know that S1P is 2R and radius of both the circle is root 2. So there will be 2 root 2, and S2, S3, it is 4R, which is 4 root 2. Then area of this triangle will be this 1 by 2, 2 root 2 into 4 root 2, which is simply 8 square units. So area of this triangle is 8 square units, and that's your option C. It is a matching question, and it says a ray of light coming from the point 1, 2 is reflected at a point A on x-axis. We have a point on x-axis, and though it is not given, I think it should be given that this mirror, it is at x-axis. So we have this ray of light coming from this point 1, 2, and it passes through this point 5, 3. And this is this point A on x-axis. Now we will find coordinate of this point A. Now we know that light travels in a straight line. So what we'll do is we'll find reflection of this point about x-axis, and this suppose P, then this point will be this P dash, and this is 1, minus 2. Now we have P dash and Q. We can find equation of reflected ray. Equation of reflected ray will be given by y minus 3, and then slope of this line will be 5 by 4 x minus 5. Now we need this point on x-axis, and for x-axis we'll put y as 0. So we'll put y as 0, we'll get this as minus 12 by 5 plus 5, and that's your x. So this x will be simply 13 by 5. So coordinate of this point A is 13 by 5, 0, assuming mirror is placed at x-axis. That means this A, it matches with P. Now this second part is, the equation of three sides of a triangle are given. Considering these sides as diameter, three circles S1, S2, and S3 are drawn whose radical center is at. Now if three sides are given and we draw circles with these three sides as diameter, then it is the standard result that their radical center is at their orthocenter. So basically we have to find orthocenter of this triangle. And if we look at these two sides, x plus y equals 3 and x minus y equals to 5, the product of slope is minus 1, as one of the slope is plus 1 and the other slope is minus 1. It's a right angle triangle, and if it is a right angle triangle, then its orthocenter is at the point where it is making that right angle. So basically that orthocenter is point of intersection of these two lines. So if we add them, we'll get x as 4, and if we put x as 4, we'll get y as minus 1. Radical center of these three circles, it is at 4, minus 1. That means this B it matches with Q. So B, it matches with Q. Now we have this third question. If the straight line intersects the circle at points P and Q, then coordinate of point of intersection of tangents drawn at P and Q to the circle is. So let this point of intersection be A and let it be alpha beta. Now if this is point of intersection, then equation of chord PQ, it is given by T equals 0. So this equation will be alpha x plus beta y minus 25 equals to 0, and this equation will be same as this x minus 2y plus 1 equals to 0. So from here we'll get alpha upon 1 beta upon minus 2 equals minus 25 upon 1. So value of alpha is minus 25 and value of beta is 50. So corner of this point is minus 25 comma 50. That means this C, it matches with R. So this C, it matches with R. And finally we have this fourth question, which is equation of three sides of a triangle are given. Then we will find circumcenter of this triangle. Now clearly if we look at it, one of the side is x equals minus 3 by 2, which is a line parallel to y-axis. This is x equals minus 3 by 2, and then we have this line which is 3y equals 4 or y equals 4 by 3, which is a line parallel to x-axis. Y equals 3 by 4. So this is x and this is y. So essentially it's a right angle triangle. And then this third line, it is 4x plus 3y plus 9. Now we can find point of intersection of these two lines. So we put x as minus 3 by 2. We'll get this as minus 6 plus 3, y equals to minus 1. So there will be minus 3 by 2 comma minus 1. And then we will find point of intersection of this line, y equals 3 by 4 with this given line. Now we put y as 4 by 3. This actually is y equals 4 by 3. So if we put y as 4 by 3, it will be x equals minus 13 by 4. So this point will be minus 13 by 4 comma 4 by 3. So it is this triangle. Now we know that circumcenter of this triangle will be midpoint of, say, PQ. So circumcenter will be midpoint of PQ, and midpoint of PQ is minus 13 by 4 minus 3 by 2 comma 2, and here it is 4 by 3 minus 1 by 2. Now this is minus 13 minus 6 minus 19 by 8, and here this value is 1 by 6. So this D, it matches with S. So answer to this question is PQRS. Now here the question is, tangents are drawn to the circle x square plus y square equals to 1 at its intersection point with this variable circle. The locus of intersection of tangents is a straight line, then slope of that straight line is. Now we have to find locus of intersection of tangents. So let this locus be this point P, which is alpha beta. From this point, tangents are drawn to this circle. So we can write equation of chord of contact, and that will be given by t equals to 0, and it will be this alpha x plus beta y minus 1 equals 0. Now this chord of contact is actually common chord between the two circles. So we can write this equation using radical axis. So for the two circles, we'll write radical axis. So we subtract second from first, we'll get this equation as lambda minus 3x plus 2 lambda plus 2y, and then this is plus 2 plus 1. So plus 3 equals 0. Now both the equations, they represent the same line. So we get alpha upon lambda minus 3 equals beta upon 2 lambda plus 2, and this is equal to minus (1 by 3). Now what we'll do is we'll eliminate lambda here. So we'll get minus 3 alpha equals lambda minus 3 or lambda equals 3 minus 3 alpha. And here we'll get 2 lambda plus 2 equals minus 3 beta or lambda equals minus 3 beta minus 2 upon 2. Now we equate lambda, then we'll get 3 minus 3 alpha will be equal to minus 3 beta minus 2 upon 2. So we get 6 minus 6 alpha and is equal to minus 3 beta minus 2, or equation of this line will be 6x minus 3y minus 8 equals to 0, and slope of this line is minus coefficient of x upon coefficient of y, which is simply 2. So answer to this question is slope of this straight line is 2. Now here the question is, we are given this set S, which is basically points lying on this circle whose center is at 5, 0 and radius is 3 units. So we have this circle, center at 5, 0 and radius 3 units. And it says the largest value of y by x. Now if we take y by x and join it through origin, then y by x is equal to tan theta, and we'll get maximum value of y by x if this line, it is tangent to the circle. So we have to find slope of this line, and that slope will be equal to y by x. Now this m, it is equal to tan of highest value of angle, and this is say alpha. Now if we join this is 3, this is 5 and this is 4, then maximum value of tan alpha is 3 by 4, which is given as m by n. So this m, it is 3 and n, it is 4. Now they are looking for m square plus n square, which is nothing but 25. So the value of m square plus n square is 25, and that is the answer to this question. Now here the question is, 3 circles with radius 3, 4 and 5 centimeters touch each other externally. So we have 3 circles and they have radius 3, 4 and 5, and they touch each other. Now we join these centers, it will form a triangle. Now suppose this is P, Q and R. Now this distance is 3, this radius is 4 and this radius is 5. Now it says, if A is point of intersection of tangents to these circles at their point of contact. Now if we draw tangents to the 3 circles at their point of contact, they'll meet at this point, which is their radical center, and which in this case is in center of this triangle. So from here, length of tangent is equal to r. So basically we have to find in radius for this circle. Now what we'll do is we'll solve this question generally and we'll work out a formula for this. So we have 3 circles of radius r1, r2 and r3. The 3 sides, they'll be r1 plus r2, r2 plus r3 and r3 plus r1. Now S is a plus b plus c by 2. So S is r1 plus r2 plus r3. Now we can find area of this triangle, and area of this triangle is under root of S, which is r1 plus r2 plus r3 into S minus a, S minus b, S minus c. So there will be r1 into r2 into r3. Now we know that r is delta upon S. So there will be under root of r1 plus r2 plus r3 into r1, r2, r3 upon r1 plus r2 plus r3. So we get this formula, which is under root of r1, r2, r3 upon r1 plus r2 plus r3, and that is the value of in radius, which is distance from point of intersection of tangents to their point of contact. Now we can put the value of r1, r2 and r3. So now we can write this r as under root of 3 into 4 into 5 upon, and this is 3 plus 4 plus 5, and that is 12. So value of r is under root 5, and that's your option C. Now here the question is, a line meets the coordinate axis in A and B. A circle is circumscribed about this triangle OAB if M and N are the distance of the tangents to the circle at the origin from the points A and B respectively, then diameter of circle is. So here we have coordinate axis X and Y, and then we have this line which meets the coordinate axis in A and B. So we have these points A and B, and suppose A is A comma 0 and B is 0 comma B, and here this angle it is 90 degrees. Now it says we draw a circle circumscribing this triangle OAB. So we have this circle circumscribing this triangle OAB. Now it says we have drawn a tangent at O, and length of perpendicular from tangent to these points A and B, they are M and N. So this is M and this is N. We have to find diameter of the circle. Now we know that equation of this circle will be given by x minus a into x plus y into y minus b equals 0. So it will be this x square plus y square minus ax minus by equals 0. Now we can find equation of tangent to this circle at x equal to 0 through t equals 0. Now this is 0x plus 0y. It will be this minus a x plus 0 upon 2 and minus b y plus 0 upon 2. So equation of this tangent is given by ax plus by equals 0. Now we find length of perpendicular from A will be this m, and then it will be this a square upon under root of a square plus b square, and the same way if we find m, it will be b square upon under root of a square plus b square. Now diameter of the circle is AB, which is simply under root of a square plus b square. So what we'll do is we'll add these two. So if we add these two, we'll get m plus n equals a square plus b square upon under root of a square plus b square, which is simply under root of a square plus b square, which is AB, diameter of the circle. So answer to this question is this option B. Now here the question is, if O is origin and OP and OQ are distinct tangents to this circle. So we have this circle whose center is at minus G minus F, and then we have drawn tangents from origin for which contact points are P and Q. That says circumcircle of triangle OPQ. Now it's a standard result that circumcircle of triangle OPQ will pass through center of this given circle, and basically center of the circle will be midpoint of OC. So we are looking for this point. Now this point is midpoint of OC, and midpoint of OC is minus G by 2 and minus F by 2, which is none of these, and that's your option D. Now here the question is, tangents are drawn from a point P to this circle whose center is at 3, 2, and this point P, it is at 1, 8. Now circumcircle of this triangle PAB, we know that it will pass through C. So this is A, this is B, and this point is C. And this PC, it is going to be diameter of this circumcircle. So center of this circle says C dash, it is midpoint of PC, and midpoint of PC is 2 comma 5, and its radius is distance of center from P. So it will be this under root of 1 plus 3 square, and there will be under root 10. So equation of this circumcircle will be x minus 2 square plus y minus 5 whole square, and will be equal to 10, or we can write x square plus y square minus 4x minus 10y plus 19 equals 0, and that's your option B. Now here the question is, if C1, C2 are circles of unit radius with center at 0, 0 and 1, 0. So we have two circles with centers at 0, 0 and 1, 0. So we have this one circle and then this other circle, and radius of both the circles is 1 unit. That says C3 is a circle of unit radius passing through centers of C1 and C2. Now this is C1 and this is C2, and we have this third circle which passes through centers of C1 and C2, and its radius is also 1 unit. Now we have to find equation of common tangents to C1 and C which does not pass through C2. So basically we have to find equation of this tangent. Now we know that center of this third circle will pass through this line, which is a line passing through midpoint of 0, 0 and 1, 0. So this point is 1 by 2, 0. So x coordinate for the center, it will be given by 1 by 2, and suppose this is k. Now we know that distance from center to any point on the circle, it is equal to 1 unit. So we'll get 1 by 4 plus k square equals 1, or k square is 3 by 4. Value of k is plus minus root 3 by 2, and since this center, it lies above x-axis, so it is root 3 by 2. So center of this third circle will be at 1 by 2 comma root 3 by 2. Now since both the circles, they have equal radius, this tangent will be parallel to line joining their centers. So we can find slope of line joining their centers, and suppose it is m. So this value will be simply root 3. So that means slope of this line is also root 3. And once we have slope of line, we can find equation of this tangent for this circle, x square plus y square equals to 1, using slope formula. So we know that equation of tangent is given by y equals m x plus minus r under root 1 plus m square. So this equation will be y equals root 3x plus or minus 2. Now there will be two such tangents. We are interested in this tangent where y-axis intercept is positive. So equation of this tangent is given by y equals root 3x plus 2 or root 3x minus y plus 2 equals to 0, and that's your option B. Now here we given a circle whose equation is x square plus y square equals a square. So we have a circle. Now center of this circle is at origin and radius is a. So we have this circle. Center at origin and radius a units. Now it says there is this another circle C1 of radius b touching this circle externally and having its center on positive x-axis. So we have this another circle of radius b with center on x-axis and which touches this given circle. So this is b and center of this circle is a plus b comma 0, and then it says this is c and this is c1, and then it says there is this another circle C2 of radius C which touches C1 externally and has its center on positive x-axis. So we have another circle C3 which touches this circle and its radius is C. Now this is a plus 2b plus c comma 0. Now it says given that a is less than b is less than c, then three circles will have a common tangent if which of the following is true. So now these circles, they have a common tangent. Now we know that if three circles, they have a common tangent and they touch each other externally, then their radius, they are in GP. It's a standard result. So basically A, B and C, they are in GP, and that's your option B. Now here the question is, A and B are 2 points on x-axis and y-axis respectively. So we have x-axis and y-axis, and we have 2 points A and B on x-axis and y-axis respectively. Now two circles are drawn passing through origin having centers at A and B. So we have drawn two circles passing through origin. Now they have given the answers in terms of A and B. I think they forgot to mention that this point A is at A comma 0 and this point B is at 0 comma B. Now here this is B and this is A. So equation of this circle is x minus a square plus y square equals a square, which is x square plus y square minus ax equals 0. And equation of the second circle is x square plus y minus b square equals b square, or x square plus y square minus by equals 0. Now first is equation of common chord. Now we know that common chord is given by radical axis, and radical axis is s1 minus s2 equals to 0. So this equation is given by s1 minus s2 equals 0. So we get this as minus ax plus by equals 0. That means this option A, it is correct. So basically this line is y equals a upon bx. Now it says midpoint of the common chord is this value. Now if we join these two centers, then basically we'll get midpoint of this chord. Now equation of AB is x upon a plus y upon b equals 1. Now we'll put y as a upon bx. So it will be this x 1 upon a plus a upon b square equals 1. So this x will be ab square upon a square plus b square. Now we put x as this value, then we get y as a square b upon a square plus b square. So this y will be a square b upon a square plus b square. So coordinate of this point M will be ab square upon a square plus b square comma a square b upon a square plus b square. That means this option B is also correct. Now C is AB bisects the common chord. Now it's a very standard statement. Line joining centers bisect chord of the circle. That means this option C is correct. And D is AB is perpendicular to the common chord. This also is a known fact. That's your option B. So the correct options are A, B, C and D. Now for C and D, we can also solve this using geometry. Now we consider two triangles OBM and BMC. Now OB equals BC, BM is common, and these two angles, they'll be same. So these two triangles, they are congruent. So essentially this M is midpoint of OC and this angle, it is 180, and half of this angle is 90. So basically these two angles, they are 90 degrees. Now here the question is, we're given 2 points P and Q, and 2 circles are drawn through these points touching the axis of y. Now what we'll do is, we'll first write equation of family of circles passing through 2 given points. And this equation, it is given by x minus a into x minus 4a plus y minus 5a into y minus a plus lambda, and this is x y1, and this is a 5a1, and this is 4a a1, and it is equal to 0. Now we simplify this, we'll get this as x square plus y square minus 5ax minus 6ay plus 9a square plus lambda 4ax plus 3ay minus 19a square equals 0, and we'll take this a with the constant, so we can write this equation as x square plus y square minus 5ax minus 6ay plus 9a square plus lambda, and this is 4x plus 3y minus 19a equals 0. Now from this family of circles, we need to find a circle which touches y-axis. Now if it touches y-axis, then y-axis intercept is 0. So what we'll do is, we'll find its point of intersection with y-axis, and for y-axis we'll put x as 0. Now if we put x as 0, we'll get this equation as y square minus 6ay plus 9a square plus 3 lambda y minus 19a lambda equals 0, or we can write this as y square plus 3 lambda minus 6ay plus 9a square minus 19a lambda equals 0. Now since it touches y-axis, there should be only one point of intersection, and if a quadratic equation has only one solution, that means value of d, it must be 0. So we'll get 3 lambda minus 6a whole square minus 4 into 9a square minus 19a lambda, it should be equal to 0. So we simplify this, we'll get this as 9 lambda square 36a square 36a lambda minus 36a square 76a lambda equals to 0. Now this 36a square will cancel. We'll get this as 9 lambda square plus 40a lambda equals to 0. So value of lambda is either 0 or it is minus 40a by 9. Now if we put lambda as 0, then one of the equation is x square plus y square minus 5ax minus 6ay plus 9a square equals to 0, in which case center is at 5a by 2 comma 3a, which is your option C. So if you put lambda as minus 40a by 9, then by simple calculation we can prove that this circle will be x square plus y square minus 205 a by 9x minus 174 ay by 9 plus 841 a square by 9 equals 0, and its center is at 205 by 18 and 174 divided by 9 into 2. Now this is 87 and this is 29 by 3. So it will be this 29 a by 3 That means the other center, it is at B. So the correct options are B and C. Now it says, find the angle of intersection of these circles. Now we know that the two circles, they intersect at this point P, which is A, 5A, and Q, which is 4A, A. Now we'll find slope of tangents at their point of intersection at P. Now we differentiate this first equation, we get 2x plus 2y dash minus 5a minus 6ay dash equals 0. So here y dash will be 5a minus 2x upon 2y minus 6a. Now here x is a and y is 5a. So it will be this 3a and this is 4a. So value of m1 is 3 by 4. And if we differentiate the second one, we'll get 2x plus 2y dash 205 a by 9 minus 174 a by 9 y dash equals 0. Then here y dash will be 2x minus 205 a by 9 upon 174 a by 9 minus 2y. Now again we'll put x as a and y as 5a. So it will be 2a minus 205 by 9a, and here it is 174a by 9 minus 10a. Now this is minus 187a, and here it is 84a. Now we can find angle of intersection. Now this angle of intersection tan theta will be m1 minus m2. So it will be this 3 by 4 plus 187 by 84 upon 1 minus 3 by 4 into 187 by 84. Now this is 1000 upon 225. Now this is 40 upon 9. So this angle will be tan inverse 40 upon 9. And that's your option B. Now this third one is, if C1, C2 are centers of these circles, then area of triangle OC1, C2. Now we know that area of triangle, it is given by 1 by 2, small sign, 0, 0, 1, and the two centers, they are at 5a by 2, 3a1, and 205 a by 18, 29 a by 3, and 1. So it will be this 1 by 2, and it is 5 into 29 by 6 a square minus 205 into 3 upon 18 a square. Now this is 6. So it will be 5a square. And that's your option B. So answer to this question is BC for this first one. Second is B and third is also B. Now here the question is, a circle of radius 1 is inscribed in an equilateral triangle PQR. The points of contact of C with the sides PQ, QR and RP are D, E and F respectively. The line PQ is given by the equation root 3x plus y minus 6 equals 0, and the point D is 3 root 3 upon 2 and 3 by 2. Further, it is given that the origin and the center of the circle are on the same side of PQ. Then which of the following they are correct? So we have this triangle PQR, And there is a circle C which is inscribed in it. So what we'll do is we'll first draw this circle C, and then we have this triangle PQR. So this is P, this is Q, and this is R. This is the circle C. Radius of the circle is 1 unit. The point of contact of C with the sides PQ, QR, and RP are DEF. So this is D, this is E, and this is F. And we are given this line PQ, and PQ is root 3x plus y minus 6 equals 0. And coordinate of this point D, it is 3 root 3 by 2 comma 3 by 2. Now let the center be h comma k, and we know that perpendicular distance from the center or foot of perpendicular from center on this line will be equal to coordinate of this point D. So we'll straight away use foot of perpendicular formula. Now perpendicular distance from the center, it is equal to radius, so we'll get mod of root 3h plus k minus 6 upon 2, and it will be equal to 1. And we know that foot of perpendicular from center to this PQ will be this coordinate D. So we can straight away write 3 root 3 by 2 minus h upon root 3, it is equal to 3 by 2 minus k upon 1, and it will be equal to minus, and then it will be this root 3h plus k minus 6 upon 4. Now we know that root 3h plus k minus 6, it is equal to plus or minus 2. So then this value will be plus or minus 1 by 2. Now if we take this plus sign, then we'll get 3 root 3 by 2 minus h is equal to root 3 by 2. Then value of h will be root 3. And here 3 by 2 minus k, it is equal to 1 by 2. Then the value of k is 1. So this center will be at root 3 comma 1. And if we take this minus sign, then we get 3 root 3 by 2 minus h minus root 3 by 2 and 3 by 2 minus k, it is equal to minus 1 by 2. Now in this case, value of h is 2 root 3 and value of k is 2. Now in the question, additional information is given that origin and center, they lie on the same side of PQ. Now if we look at equation of PQ, it is root 3x plus y minus 6 equals 0. If we put x and y as 0, we'll get this as minus 6, which is less than 0. So out of these 2 points, we have to choose the point for which this value is negative. Now if we put root 3 comma 1, we'll get this as 3 plus 1 minus 6, which is minus 3, less than 0. So this point, root 3 comma 1 and origin, they lie on the same side. And if we take 2 root 3 comma 2, then this value will be plus 2, which lie on the other side of origin. So in this case, center of this circle is at root 3 comma 1. So this center, it is at root 3 comma 1. Now once you have center and radius, we can write equation of this circle. So equation of this circle is x minus root 3 whole square, y minus 1 square, and will be equal to 1. And that's your option D. Now the next question is we have to find these points E and F. Now what we'll do is we locate the circle more precisely on coordinate axis. So we can draw it like this. Now we know that this angle is 120 degrees. Since this equation is root 3x plus y minus 6 equals 0, slope is minus root 3, that is 120 degrees. Now the other two sides, they'll make an angle 60 degrees. So one of the side will be x-axis, and we'll have this other side here, which is going to make an angle 60 degrees. So we have to find these 2 points. Now say this is E and this is your point F. Now center of this circle, it is at root 3, 1. And this is your point D. This is P, Q and R. Now we know that this is x-axis, so this line will be perpendicular to x-axis. So coordinate of this point F will be root 3, 0. So coordinate of this other contact point F, it is at root 3, 0. And we have to find coordinate of this point E. There are many ways to solve this, and one of the ways we can draw this line, say CE. Now this angle is 60, this is 90. That means slope of this line is root 3 and slope of EC is minus 1 by root 3. Now slope is minus 1 by root 3, that means theta is 5 pi by 6. Now what we can do is we can write equation of this line EC in terms of parametric coordinates. So this equation will be x minus root 3 upon cos 5 pi by 6, and that is under root 3 by 2 y minus 1 upon sin 5 pi by 6, which is 1 by 2, and will be equal to plus or minus 1. Now if we take this plus sign, we'll get this as x equals root 3 minus root 3 by 2, and y minus 1 equals 1 by 2. So this point will be root 3 by 2 and 3 by 2. And if we take minus sign, then we'll get this point as x as 3 root 3 by 2 and y as 1 by 2. So basically there will be 2 points. This is E dash. I will discard E dash. We need this point E, and this point E will be this root 3 by 2 and 3 by 2. So that's your point E. So coordinate of this point E will be root 3 by 2, 3 by 2, and F is root 3, 0. That means the correct option is this option A, root 3 by 2, 3 by 2, and root 3, 0. And finally, it is equation of sides QR and RP. Now, equation of RP is very simple. It is simply x-axis. So its equation is y equals to 0, and equation of QR is y minus y1 equals root 3 x minus root 3 by 2. So it will be this y minus 3 by 2 equals root 3x minus 3 by 2. So equation of QR is root 3x minus y equals 0, and equation of PR is y equals 0. So the equations are root 3x minus y equals 0 and y equals 0. And there will be your option D, root 3x minus y equals 0 and y equals 0.